Hi, so I am going to show you this morning. I thought we could work on the review sheet a little bit together, and I'm going to show you how I'm using the Notability app. So if you have an iPad and you download this app, it is $8.99, so it was an investment. But if it's been a really great thing for our family during this online schooling, so maybe it would work for you too. So in the Notability app, I have opened our worksheet. To do that, I actually had to save it to my Google Drive off of Schoology and then upload it into Notability. And that's done now. And I've also chosen my marker. So like here under the pencil, where did it go? Under the pencil here. I've chosen like purple and like that size. And I had to play around with the sizes to get one that works. So now I'm just going to do this with my finger. This is our worksheet, and I thought I'll help you with just half of it, basically, like we do in class sometimes, and that'll help you get them done. So we're done with all our shapes, right? All the formulas are given to us. They're all here at the top. So if I'm going to do the perimeter of the base, right, this is my base here. Let's see if it'll let me like shade it in. No. So my base here is 12 plus 2 plus 12 plus 2. And of course, you don't have to write that down. So that's what 14 and 14 is 28. And what I like about it is I can zoom in here and then just write it. Sometimes it's 28 centimeters. So, I mean, it doesn't look perfect, right? But I didn't have to print it out, so that's good. A lot of times I get a stray mark there. If I do, I just come up here to undo, and then it's gone. Height of the prism, of course, is 5 centimeters. And then for the lateral areas, perimeter base times height. So 28 times 5, 140, area square, centimeters squared. Perfect. Area of the base, we know the base is a rectangle, so it's 12 times 2, or 24 centimeters squared. And of course, I have two bases, so 24 times 2 is 48 centimeters squared. If I had a stylus, it would probably work a little better, but I'm just using my finger. 140 plus 48, right? Oops, that's how I'm going to get the total area. So 140 plus 48 is 188 centimeters squared. Perfect. So if I zoom back out there, there's an example of a prism, right, for lateral area, total area. I'll let you do this prism on your own, just pointing out that the triangles are the base, and you have to use Pythagorean Theorem, right? 6 squared plus 8 squared equals x squared. I don't know, should we do them all together? Maybe I'm feeling like we should do them all together. 6 squared plus 8 squared equals x squared. So we've done this problem like 8,000 times, right? So this is 100, and the square root of 100, of course, is 10. So when I do the perimeter of the base, it's 6 plus 8 plus 10, which is 24 feet. The height of the prism is the 12. Height connects the two bases, right? So the 12 is actually the height. I'm going to multiply 24 times 12, 288 feet squared. I have to be careful with the area of the base, of course, because the base is a triangle. So it's not 6 times 8, but 6 times 8 divided by 2 is 24 feet squared. There's two of them, 48 feet squared. And now I'm going to add 288, and 48 is 336 feet squared. That's it. Okay, so I think I have... Oh yeah, volume, right? Yeah. Okay, so there we go. So volume is area of the base times height, right? So area of the base, 12 times 2, zoom back in here, is 24. 24, let's see if it'll write it. 24. So it's tricky, not gonna lie. Let's see, 24, there we go, centimeters squared. 24 centimeters squared. Height is 5 centimeters, and then I'm going to multiply 24 times 5 is 120 centimeters squared. Cubed, actually, centimeters cubed. Area is squared, volume is cubed. We have that same one again, so we know the area of the base, 6 times 8 divided by 2 is 24 feet squared. height is 12 feet, and then we're going to multiply 24 times 12, again, 288 feet cubed. Just happens to be the same answer there. For exact radius diameter, this is just a little review before heading into cylinders. We know that the radius here would be 6 millimeters. The diameter, of course, 12 millimeters. So exact circumference, 12 pi millimeters. An exact area, 6 times 6 is 36 pi millimeters squared. Doing one more approximate, right? Now we've got a radius of 2 feet, diameter of 4 feet. If I take 4 times 3.14, that's how I'm getting 12.56 feet. Approximate, 2 times 2 times 3.14 happens to be the same thing, 12.56 feet squared, area square, yeah. So now I'm ready to go on to, let's see if I can get it here, go on to my cylinder, right? So cylinder here, it looks like the radius is 8 and the diameter therefore is 16. So 8 and 16, come on, 8 and 16. If I had a stylus, it would work better. Eight inches, 16 inches. There we go. Exact circumference would be 16 pi inches. Height, of course, is 15 inches. Exact lateral area is circumference times height, so 16 pi times 15, I'm just going to write it over here, is 240 pi inches squared. Maybe I need to zoom in a little bit more. 240 pi inches squared. That should go with lateral area. Area of one base, 8 times 8 is 64 pi inches squared. Of course, there's 2 of them, so 128 pi inches squared. And then I'm going to add the 240 and the 128 gives me 368 pi inches squared. Perfect. That was our exact cylinder. If we scroll over here, then I can do my approximate cylinder. This one looks like it has a radius of 6 and a diameter of 12. Approximate circumference, pi times diameter, so 3.14 times 12. You don't have to write that down, but that's how I'm getting the 37.68 inches. Height, of course, is 10. If I multiply those two together, 376.8 inches squared. Area of one base, well, radius was 6. It's approximate, so 3.14 times 6 is the 113.04 inches squared. And then if I double that, 226.08 inches squared. And then I'm going to add those two together, right? 376.8 plus 226.08 is 602.88 inches squared. And that's cylinder. Right, moving right along. Okay. Actually, we didn't totally finish cylinder because we've got to do the volume. So I'm going to come over here and one more cylinder. This one's got a radius of 3. It's got a height of 16. Do one exact and one approximate. So I only asked you for the radius. That's really all we need there. So the radius is 3 centimeters. 3 centimeters. Come on. So I'm not going to lie, it's a little frustrating. 3 centimeters, there we go. Exact area of the base, pi r squared, so 3 times 3, of course, is 9 pi centimeters squared. The height is 16 centimeters, and we're going to multiply those together, 144 pi centimeters cubed. Volume is cubic area, cubic units, sorry. If we come over here, approximate, now our cylinder is sideways, so I see that the diameter is 10, so the radius is 5, so 5 centimeters. Approximate, 3.14 times 5 is going to give me 78.5 centimeters squared. Height connects the two circles, so that's our 15 centimeters. And then we multiply those together, 1177.5 centimeters cubed. That's the volume of the cylinder. Only a couple shapes left. We got pyramids and cones, right? Pyramids and cones. So these formulas are all given to you here. Remember that there's no pies in pyramids. No pies in pyramids. So our perimeter or our base here is 5 plus 5 plus 5 plus 5, or 20. Doesn't seem to like it when I start a new shape. 20. There we go, 20 centimeters, or no, it's yards, 20 yards. The slant height, that's that L, that 4 yards. And then if I just follow my formula, slant height times perimeter divided by 2, that gives me 40 yards squared. Area of the base is 5 times 5, or 25 yards squared, and then I'm going to add them up to 65 yards squared for the total area. If I do the same thing for the cone, now it's like basically the same formula, right? The radius here is 8, the diameter is 16 yards. I did this exact. So exact circumference here is 16 pi yards, 16 pi yards. Slant height looks like 10 yards. And again, I'm just going to follow the formula. Circumference times slant height divided by 2, 80 pi yards squared. Area of the base, 8 times 8, 64 pi. We only have one base, so we just have to add up the 80 and 64. So now I lost it. So let's kind of see if I can get back. There we go. 80 plus 64, 144 pi. That was a pi there. And this was yards squared, and this is yards squared. If we do the volume of those two shapes, there's the formula for volume, area of the base times height divided by 3, and we know we use the real height. So area of the base here is 100 meters squared. The real height goes right through the shape. Is that 8 meters? 8 meters, not meters squared. Then we do 100 times 8 divided by 3. So that is going to be a decimal with the repeating bar, which is fine, meters cubed. That happens a lot when you divide by 3. Here I did approximate. The radius here is 9 inches. 3.14 times 9 times 9, 254.34 inches squared. Height is given to us at 7. And then I'm going to multiply 254.34 times 7 divided by 3 is 1780.38. 1780.38 inches cubed. And our last shape is our sphere, right? Sphere, we only need the radius. The radius is 5. I did one exact, one approximate, 4 times pi times 5 times 5 is the area. So that turns out to be 100 pi feet squared. And if we do approximate, we just would replace the pi with 3.14 and get 314 feet squared. For the volume, the radius here is 6, right? Diameter 12. Volume formula, 4 times pi times 6 times 6 times 6 divided by 3. You don't have to write that down, but I'm just going to show you where we're getting it. Divided by 3. If I plug all that in, and it said exact, so I don't need the 3.14, it's just 288 pi inches cubed. Inches cubed. Okay. So you can see there's like little frustrations, but here we go. We're almost done. Volume, if I replace it to approximate, 904.32 inches cubed. And now we're home free. We just have our last formulas here with the faces, edges, and vertices. We can tell that that's a pentagon, so the end there is 5. You can use the formula, or you can count to see that there's 7 edges, there's 12 corners, there's 7 faces, 12 corners, and 18 edges. And if it was 50, if n is 50, n plus 2, of course, would be 52. 2n would be 100, and 3n would be 150. So yes, there it is, using Notability and my finger. It's not pretty, but I have the whole worksheet. And then if I wanted to upload this to Schoology, what I would do is come over here to the plus sign here, I believe. No, I'd come over here to the upload right here. And it asks what I want to send it to. You can choose other apps, and Schoology might be one of them. Or a lot of times I add it to my Google Drive. I'll put it under like a classroom folder or whatever folder. I don't even need a folder, and I can export it there to my drive. And then it'll be on my Google Drive, and I can upload it from my Google Drive to Schoology. So hopefully that helps, even if it was just watching the answers. That's it.